Hi, my name is Nidhi Mathihalli, and my project is a money reader for the visually impaired. Did you know that there are over 285 million people in the world who are blind, one of which is my grandfather? Due to his extreme anxiety around handling money following his loss of vision, I decided to help him by creating a device to help him be more financially independent. After doing some research, I realized that the only options in the market right now are apps or the iBill, both of which are extremely expensive. I also visited and spent some time with students in the Sri Ramana Maharshi Academy for the Blind in India, who told me that the best way to solve this problem would be to create a cheap, robust, and effective way to read money using a physical prototype. This is because apps on phones are hard to use because of their small screens. I looked into ways to create this device and decided that the best way would be to use a Raspberry Pi, an ESP32 CAM module, and a battery breakout board, which would only result in $25, whereas the iBill is $220 and smartphones are $500. I then created a plan. The first step was to create and improve the machine learning model. The original model was created using TensorFlow and Keras libraries. From there, I tried various different approaches, including the Google Vision API, binary classification, filtering data, KNN feature detection, and transfer learning. These results can be seen on the screen. The code for these various approaches can also be found in the description below. This past year, I also worked towards productizing the device, learning how to CAD and how to solder. As a result, I was able to productize and greatly reduce the size of the ESP CAM module as well as the Raspberry Pi device itself. Once I'd completed these steps, I decided to test my device. So right now we're testing the money reader device. So we turned it on a couple seconds ago and it's waiting for the picture to be taken. So right now, it says take picture script has started, original files have been deleted or URL found, and it's waiting for the camera. So now it's taken the picture and it's downloaded the image, right? So it takes a couple seconds for it to actually identify the bill. Okay, so it's identified this bill as a $10 bill. As you can see, it works on the back as well, and we tested it out and it works on the front. However, we aren't able to share the audio with you since it comes out through headphones only. However, one thing we have discovered is that since we use our own Wi-Fi for this ESP32, or for the Raspberry Pi, and the ESP32 is a Wi-Fi camera that's connected to it, we can easily show you what the ESP32 is looking at. So right now, it's my phone, as you can see, and the ESP32 is streaming from this URL, and this is the $10 bill that we just took a picture of, and this is our money reader device. So as you can see, this ESP32 clearly works with this money reader device, even if it's out in public and not connected to any home Wi-Fi. Thus, we know that this device works. Yay! Currently, I'm working with many blind schools in India in order to ship devices there. In addition, I have created a nonprofit organization called Helping Vision, aimed at creating and distributing AI technology for the visually impaired in third world countries. Through this organization, we are reaching out to many blind schools in India in order to create a positive impact. Overall, I learned a lot, both technical and life lessons. One of the biggest lessons I realized was that I could write a book on the number of times I failed, but less than a page on the successes. However, both were important. The failures gave me perseverance, and the successes, which felt huge, kept me from giving up. Overall, I hope to work with more blind schools to ship these devices. As previously stated, the cost of my money reader is almost 10 times cheaper than those currently on the market. As such, it is much more accessible to those in third world countries. In the future, I hope to expand the abilities of the device to increase the visually impaired person's awareness and help them with navigation. Thank you and have a great day.